wanted to go over because one of them turned out that several of you guys interpreted it in one way, and then you get one solution, and if you interpret it in a different way, you get a different solution. That was the optimization problem. So if we have a rectangle and then we put a semicircles on either end, we wanted to, what was the perimeter given in this one?
400.
Yeah,
400. And we wanted to maximize the area. Okay. So great. The interpretation here, and when I reread it, it was a little unclear, and so it made sense why some of you went both ways. If you were to build a track, would you put fence down the middle of the track here and here? Probably not, okay? But if you assume that you do, that changes the solution, okay? So what I thought I would do is actually work it both ways because the solutions are kind of interesting both ways. Okay, so let's say that this segment here is y and that segment there, which is the diameter of the circle, is x. Okay, so case one, assume no fence inside. Okay, in that case, the perimeter formula, which is the 400, right, would just be what?
I think when people got confused was with the part where the corn was growing in the middle, so you wanted to see what was fenced around the corn.
Yeah, but the corn would also be growing here, here, and here,
Oh,
right? And so what's the point of putting the fence right there? Right? Yeah, so I took it both ways because it made sense that it was it's sort of ambiguous. Okay. All right, so if you assume that there's not those internal fences, then the perimeter would just be 400 is the total that we have to work with, okay? But that would be 2y, the two rectangular pieces, plus pi times the diameter, which is in this case x. Right? Okay, because 2 pi times x. Because what's the circumference of a circle?
pi times the diameter.
Yeah, sorry, it is just pi times, not the 2 here. X is my diameter, not my radius. If you make it your radius, then obviously you need a factor of 2 there, right? Is that okay?
Mm-hmm.
All right, so then the thing we want to maximize is x times y is the rectangular part of the area, plus what's the circular part of the area? Pi r squared. Now what's the radius here? Yeah, so it'd be pi times x over 2 squared. Okay? And I had to divide by 2 because I made x my diameter rather than my radius. If you make x your radius, then that'll change the formulas a little bit, but you'll end up with the same answer in the end. Okay. Okay, so we need to solve the perimeter expression here for one variable in terms of the other, and in this case, I'd rather solve for y. Okay, so y would be 200 minus pi halves x. Yes? Okay, so substitute that in for y in our area formula. And then I'm going to go ahead and simplify here and just rewrite that term. Okay, and I'll go ahead and multiply out that term like so, and then I can simplify one more step by combining. I've got plus pi over 4 minus pi over 2 would be minus pi over 4. Okay? All right, good? So now what? That's A. That's what we want to maximize. While we're at it, actually, what are the restrictions on our variables here? X has to be bigger than or equal to 0. Y has to be bigger than or equal to 0. Right? And obviously the total perimeter has to add up to 400, so that kind of constrains things. All right, so I need to take a derivative. Okay. Set it equal to 0. And what does that make x?
2 pi over 4, so pi over 2, x.
So it'd be 400 over pi. Right? Okay, now if that's the case, then if I substitute that back into my formula for y, what do I get for y? Yeah. Okay, now and at first you look at that and you say, wait a minute, I've definitely screwed something up because I got y equals 0. Okay? But let's go back to the picture and interpret what this would mean if y equals 0. What shape would our thing be? It would just be a circle, okay? And so what you guys basically just discovered is something that Zenodorus proved, several thousand years ago, right? Of all shapes, what shape encloses the most area for a given perimeter? A circle, okay? And this happened because, essentially, it is reasonable for y to equal 0 here. That just means that you don't have the rectangle part in the middle, right? Now, if I was trying to build a football field here, that wouldn't work very well, right? But if all I was trying to do was enclose some corn and have a track around the outside, nobody said that there had to be straight segments on it in the end, okay? So this is actually an endpoint solution where the y part is 0, right? That was the minimum that y could be, and it turns out that's exactly what it needs to be, okay? But this is assuming that you do not have internal fence. If you do have internal fence, then that'll change the computation. Okay, so does that kind of make sense? Okay, so yeah, you get an endpoint solution. Okay, any questions on case 1? Because I'm going to go over to a new sheet for case 2. No. All right, so let's go to case 2. What changes this time is our perimeter formula, because now we have our old perimeter formula, which was 2y plus pi x. But now we also have 2 x's, okay, because we've got those 2 internal segments. The area formula remains the same because I'm still enclosing the same geometric area. Still enclosing the same area, okay? So what this will change is, what's going on here? What should that be? Pi x? Yeah, okay. And then the 2x. Yeah, so we got y here, we got x there, right? So we've got pi x is the circumference of the circular part. 2x is the the two straight pieces, and 2y are the two other straight pieces. Okay, so we good with that? Okay, so if I solve for y in terms of x this time, then I get this. Pi over 2 x. Sorry, pi x over 2. Yeah? Okay, so now substitute that in to our area formula. And then let's multiply it out like before. Sorry, that should be over 4 here, like it was before. Okay, combine those terms. This is minus pi over 4 x squared. Okay, so good. So we just have the new term, right? All right, so now if we take a derivative, then we get this. And so then if we set that equal to 0 and solve, then what does that make? So we'd have 2x plus pi over 2x equals 200. Factor everything out. So x times 2 plus pi halves equals 200. And so x would be 200 over, or hold on. Yeah, 200 over 2 plus pi halves. Okay, whatever the number that is. Okay, does that make sense? Okay, now how do we know that we've achieved a maximum? With the previous case, we knew this because we'd actually stumbled on an endpoint solution. Okay, but in this case, how do I know that this is going to maximize my area? Well, what's true about a double prime? Well, it's clearly negative because the derivative of 200 is 0, but what's the derivative of these two linear terms? They're the coefficients, which are both negative, okay? So if the second derivative is negative, what does that mean that we've gone through? It means our function's concave down, and at the point in question, that means we've gone through a maximum. Yeah? Okay, so I took this one either way because I could see why it was ambiguous which way you did it. And I wasn't trying to be diabolical with it, but it kind of turned out that way in the end. Okay. Any questions, preguntas and or fragens on that? Okay. So let's see. There was one other one I wanted to go over. Sure.
The first one is the where you intended it to be?
I think so, yeah, but I was trying not to be too diabolical. Okay, yeah, let's also do the fundamental theorem of calculus one. All right, so this was I in 5. We had f of x equaled 0 to the natural log of x of the cube root of t squared plus 27 dt. Okay, so we needed to if we want to find a tangent line, what do we need to know? We need to know a point and we need to know a slope. Okay, so let's do the point first. We're given that the x-coordinate's 1, so that's nice. Okay, what about the y-coordinate? Well, what I would need to do is plug in f of 1 for x. Okay, so if I just substitute 1 in for x, then I get this. But what's the natural log of 1? Okay, so that means I'm integrating a function from 0 to 0, and therefore, what's the answer? 0, okay? Because I'm not enclosing any area. Right? Okay, so that gives us our point, 1 comma 0, and our slope, we need to do f prime of 1. Well, first, we need to get f prime of x. And so that's going to be the derivative of this. Okay, so what does the fundamental theorem say? The derivative of an integral is basically just plug in the thing at the top to the function. But what do I need to multiply by? This nailed a bunch of you.
What's inside the function?
The derivative of what? The natural log part, okay? Because the fundamental theorem assumes that that's x, not a function of x. If it is a function of x, we need to multiply by, by the derivative of it, which is, in this case, 1 over x. Okay. Now, as it turns out, forgetting that division won't actually matter numerically because x is 1 that we're going to plug in, and division by 1 doesn't do anything. But that 1 over x has to be there. Okay, so f prime of 1 would be, what do we get if we plug 1 into this? It'll just be the cube root of 27, which is 3. Okay, and so our equation is y minus the y-coordinate equals the slope times x minus the x-coordinate. Okay? All right, so I think those are the two I wanted to go over, but I'm happy to take other questions. Oh, yeah, that's, sorry, I meant to do that one too. Yeah, thanks. Oh, sorry. Has everybody got this down before I move on? Yeah. Okay, so the concentric circles one. Oh, and then I also wanted to do the position, velocity, acceleration, or the dude that stole your hat problem. Okay. The IN2, the initial value problem. Okay. Okay, so the story is we've got two circles, and the radius of both of them is expanding. Okay, and so what we're interested in is the area that's between them. Okay, there's a couple ways that you could go about doing this, and a number of you took a number of different approaches. What is the area of this piece? The stuff in between the two circles. Well, it'd be whatever the area of the outer circle is minus whatever the area of the inner circle is. Okay, so let me write it this way. Okay, and let me think of my inner radius as being r and my outer radius as being big R. Okay, or you could do r sub out and r sub in, right? Whatever you want to call it. Right? Okay, good. All right, now what information were we given? We're interested in the moment in time. How big is the outer circle? It's like 13 or something. What's it? 10? And what was the rate at which the inner circle, or sorry, the outer circle was expanding for the radius? Okay, and what about the inner circle? What were its numbers? Radius of 3 and rate was 5. Okay. So even though the inner radius is growing faster, the outer radius is much bigger, and so the question is, does this catch up or not? Right? Okay, so first thing we got to do is take a derivative, right? So a dA dt is 2 pi big R times d big R dt minus 2 pi little r times d little r dt. And now we just need to plug in the given information. And so what do we get? Let me go ahead and factor out a 2 pi from everything. That'll make the next step a little easier. Okay, so we'd have 10 times 2 minus 3 times 5. And what do we get here? Times 5, or 10 pi. Okay, so is the area in between increasing or decreasing? It's increasing because that number's positive. Okay, does that make sense? So, a number of what you guys did was you said, all right, let me just figure out the rate at which the outer area, the big circle is expanding. And you got 20 times 2 pi. Okay. And then separately figure out the rate for the inner circle. And you got 20 times, or sorry, you got, you got 30 pi instead of 40 pi. And you said, oh, well, 30 pi is smaller than 40 pi, so the bigger one's expanding more than the smaller one is shrinking it, and therefore the total area is increasing. Okay? That works. I mean, essentially what you did is you did each of these two pieces separately and then said, okay, the magnitude of this one is bigger than the magnitude of that one. So when I subtract the smaller one off, it's not gonna, it's still gonna be a positive quantity. Okay, so, yeah. Does that make sense? Okay, good? All right, any other question on fragmentus and or fragments? Okay, so let's do the dude who stole your hat. And or maybe egged the bench while you were trying to guard it. So what exactly happened? Yes, but like, what are the deets? Like, give me the gory deets here. Yeah. All right. All right, so dude steals your hat. How fast is the dude running? 13 feet per second. And he gets a 30-foot lead on you. Okay? Is that all right? And you run with a of t equal to what? 2 feet per second. Okay? But he's got this 30-foot lead on you. Okay, so if he runs at 13 feet per second, let's do you and the dude. And let's figure out the positions, velocities, and accelerations of everybody. Okay, we're given that the dude has velocity equal to 13. And that's constant. But where is the dude? He starts out at time 0 being 30 feet ahead of you. Okay? So his position is given by 13t plus 30. Does that make sense? Okay. Now, you, on the other hand, we know that your acceleration is constant. Where do you start in terms of your velocity? No, that's your, okay, we're going to say you start at 0 and he starts at 30. Okay, otherwise you have to say he starts at 0 and you start at minus 30, right? But either question actually is not relevant right this moment because we're talking about velocity. What's your initial velocity? Because you haven't started running yet, okay? So your velocity is just 2t here, okay? And then what is your position? Okay, it's just t squared. Where do you start running? At the origin, okay? Now, we could have put the origin wherever we wanted. It makes the most sense to put it where you are rather than where he is. Doesn't matter. I mean, you'll get the same answer in the end. Okay, so your velocity, or sorry, your position is t squared, okay? Does that make sense? Yeah? And what are we interested in? We're interested in the moment in time when you get your hat back. Well, when does that occur? That occurs when your position and the dude's position are the same. Okay? So, what we're interested in solving is this equation. Yes? Okay? And so, if I move everybody over, does this factor cleanly? So we need two things that multiply to give minus 30 and add up to give minus 13. Huh? 15 and 2, right, does the job. Right? Okay. So 15, but the 15 needs to be the negative one, and the 2 needs to be the positive one. Okay? All right, so what do we get for our solutions? 15 seconds, right? Because this is a time, not a distance. All right, now, what about the negative 2? Does that make sense? No, that's not relevant or reasonable given the problem. That would be like if you went backwards in time before the moment when he actually stole your hat and you moved backwards. Yeah, so that doesn't make sense. Okay. All right, so 15 seconds is when you catch him. Okay, what else did we want to know? How fast you were going, and for that all I have to do is compute v of 15 and we get 30 feet per second. Right, so once we know when something happened, we can figure out where we were, how fast we were going, etc. Okay, does that make sense? Okay, so yes.
You can also get how fast you were going with that -2, for the t was -2, because if your position is 2 and you go back, the rest of you guys were at the same, 2 seconds later he was 30 seconds
out.
Alright, is that just a coincidence?
I think so, yeah.
Man, what the hell, we on this?
Well, did you plug in -2 to the velocity formula? Or sorry, to the, yeah, if you plug -2 into the velocity formula, you get -4 feet per second. But that's not reasonable because nothing before t equals 0 has happened. Yeah. Yes. Yes, because, sorry, for some stupid reason, we use S of t for position instead of P of t or something like that. Sorry. Yeah. Or at least that's what's common in books. So, yeah, V and A being what they are is sort of obvious, but position, I mean, at least position has the letter S in it. It's kind of like slope. What letter do we use for slope? M, because the letter M totally appears in the word slope, right? Why is that? Got me.
Greek
I-
or something?
Well, or why do we use B for the y-intercept? Because y-intercept totally has the letter B in it.
Maybe because we use Y for the point slope already?
So, anyway. Okay, good. All right, so those were definitely all the ones I wanted to hit. Do we have any other question, preguntas, and/or fragens? Yes?
The geometry.
Yeah,
Oh.
okay. So, the first one was this. Okay. So, is it possible to actually do this integral? Yes. Okay. But, like, to analytically do it and not pretend that there's any geometry going on. It is possible to do it, okay, but it takes a technique from Calc 2 called Trigonometric Substitution, which you don't know yet, do you?
I think I was in high school.
Really? Oh, okay. Well, because I looked at that and I was like,
I don't
huh.
think we ever did the geometry of them.
But you did trig substitution. That's whack. So.
My high school was not.
Okay. All right. Well, that explains a little bit then. Because what was the other interpretation that I could have taken? Yeah, nefarious activity. Right. I'm glad to know it was the former and not the latter. Okay. Okay. So the geometry of this is, well, what is this? What shape is described by this equation? It's a semicircle, right? Okay, and which semicircle is it? What's the radius? Where's it centered? No idea. Okay, well, it's a square both sides. That means it's radius 3 centered at the origin. Okay? And so if I sketch that, well, this would be the curve in question. Okay, why do I know it's the bottom semicircle and not the top one? Because the function had a minus in front of it. Okay, so the equation of a circle, right, would be the whole thing. Does that pass the vertical line test? No. So I can't give a single function that describes a circle. I have to give two of them, one for the top and one for the bottom. Okay, the bottom is the one with the minus in front. Okay, now, in our case though, what is the integral in question? It's from -3 to 0. So which part of the circle is actually needs to be shaded in? That left quarter. Because 0 is here. And so that integral represents that signed area. Okay, so it's a quarter of a circle, but what's the value gotta be? Negative or positive? Why negative? Because it's below the axis. Okay, so what's the area of that quarter circle? Well, the area would be pi times the radius squared over 4, because it's a quarter circle. Okay, and so what was our radius? 3. So the area geometrically is 9 pi over 4. And so what's the integral? Yeah. Okay. So, I'm not saying that the area is negative, right? That's ridiculous. What I'm saying is that we're going to count it negative because it's below the axis, right? And the convention is area above the x-axis counts positive, area below counts negative. Okay, is that all right? We know. Okay. So that was maybe one thing. So the point of that geometry problem was not to actually do it with the fundamental theorem or any fancy pants integration techniques or anything, but just to realize what the hell what does this represent, right? I got this gobbledygook formula, right? It represents something geometrically. Well, what is that, okay? And so the formulas or the graphs that I'd give you there would be things that are like piecewise linear, which is the next one, circles, you know, shapes for which we actually have some geometric formulas. Okay? Yes, Julius.
What if the shape that you're looking for bleeds into the other side?
Then you're hosed. Okay. So, no, it's a good question, right? Let's say if it bled all the way over into the other side and we had a half circle. We're good. Just double the answer. Okay? But what about, like, so you're asking, suppose that it actually came up to like some midpoint there, then you can't do it with geometry. You can get this part, the quarter circle, easily, but this part here is not necessarily just, like, let's say that the green line is halfway between the two ends there. It's not just gonna be half the thing, right? Because what actually encloses, well, my sketch of my green line is pretty crappy. Let me put it halfway down. Does that divide it into the pizza into two equal pieces? No, the one in this one is bigger than that one. But is there any known relationship between those? Sadly, no. Well, actually, there is one, but it means you have to do the fancy pants Calc 2 version of the integral to actually do that, yeah. So, yeah, unless, the only way that we could do something and not have it be impossible for, given what we know, is if it were something like that, okay, and we knew this angle, because what's the area of a sector of a circle? So it'd be pi r squared, that's the area of the whole thing, times whatever portion that angle is, right? So if it's a pizza shape, a slice, we could figure it out. But if it's not, it's not. And can it be a pizza shape with an integral that looks like this? No, because the numbers at the top and the bottom are constants, which means both sides are straight lines, vertical, okay? Does that make sense? Yeah. Okay, so if that happens, take Calc 2. I wouldn't do that to you guys. Okay, so the last one, what was the function? It was piecewise. -1 to 4, okay. What was the function on the, from -1 to 1, it was what?
X is less than or equal
Okay, so what was it? It was -1 if x is less than or equal to -1
So it's positive.
to +1, okay. And what was the other part?
X minus 2, x is greater than
Okay, so, and we wanted to find the integral from what to what? -1 to 4 of f of x dx. Okay, so what we need to do here is let's sketch this first. Okay, it's -1 up to here. And then x minus 2 would be there. So 1, 2, 3, 4. Okay, so 1, 2. Okay, so what is the area that we're enclosing here? This stuff and, oh yeah, sorry, because it was -1 over. This stuff and this stuff. Okay, does that make sense? Okay, so what's the area of the green piece? Its base is 2, height is 2. It's a triangle, so I have to divide by 2. What's the area of the orange piece? Well, let me subdivide it. 2.5, but negative. Okay? All right, so what do we get when all's said and done? -1/2. Okay? So the area below slightly outweighed the area above. Okay, does that make sense? Now, in this case, could we have done this with the fundamental theorem? Yes, but if we did so, what we would have to do is write it like this. -1 to 1 of -1 dx plus the integral from 1 to 4 of x minus 2 dx.
Can we do that in the test, or do you want us to?
Okay, good question. I would be okay with you doing this on that problem to check your answer. Okay, but not in place of the geometry.
Is that the same thing with the fundamental theorem? You don't
No,
use-
there I do want you to do it like with the fundamental
Like,
theorem.
we can use substitution?
Yeah.
Oh.
Yeah.
I
So yeah, okay, so which way you do it depends on which question you're doing, right? The whole point of the geometry question was exactly that, the geometry, right? And the whole point of the fundamental theorem is the fundamental theorem, right? But they're two different questions, yeah.
Is doing it like geometry the same as like area under the curve?
Yes, because that's, I mean, area under the curve, like that's a geometric concept, right? Okay, does that make sense though? Does that clear that up? Yeah, okay. Any other questions?
What's our test over today?
Just the integral ones.
So the fundamental theorem?
Yeah, so IN1 and up. Okay, all right, I think we're good for today. Great.